Hi and good day to our lecturer, Professor Isman. And in this video, I'm going to present to you on our group project, our industrial engineering group project. So before that, I'm going to introduce my group members, which consists of 5 members, which are Beijing Xiang, Brian Liwaiser, Dibakaran, Anandaki Karanakaran, Lim Yong Xiang, which is me, and also Muhammad Rizwan bin Cik Mamat. So in this project, we are focusing on a few main things, which are project selection, what type of product to be used, and then the project management, the break-even analysis under engineering economy, and also discussion. We want to discuss based on our research, our findings, and also conclusion. So the first part is actually the background of the project. Basically, I'm going to summarize on this. So we have chosen ceiling fan because ceiling fan is a very common household application that almost everyone has it. Typically in a hot climate country like Malaysia, because we have a very sometimes the weather is very hot, sometimes it's we have rainy seasons, but most of the time we need ceiling fans to help to cool ourselves down. And also we have chosen KDK company because KDK is a very well-known company in producing ceiling fans. So this is why we would love to analyze the fan produced by KDK, what are the costs, what are the basic material that are involved, what are the processes that from the beginning all the way to the end stage. So also with in the skill set learned from engineering, industrial engineering, we can able to examine our product more carefully to, and then develop manufacturing and information system to meet the criteria to maximize the efficiency. So, and also we moving on to objective. So we want to analyze the problem the company is facing and we want to gain a competitive advantage by producing ceiling fan on a constant basis. And we mainly focus for the project scope is that we want to collect data using quality tools, and then we want to control and planning the project, designing the suitability of manufacturing line design, and then to analyze what are the costs that are involved to ensure that the KDK company can optimize the profit while reducing unnecessary expenses. So that's all from me. Thank you.
Hi everyone, my name is Beijing Xiang. So in this project selection, the product chosen is KDK ceiling fan. So this is our product structure that shows the components. Okay, so the fan bed is the item that we make in-house, and then this right hand side components is the item that we need to purchase from the suppliers. Okay, next. So for the demand, in the first year, the yearly demand is 9,000 units, and then this value increased to 13,000 units in year 5. So the monthly demand of ceiling fan in year 1 is approximately 750 units. So next, this is the aggregate plan and the master production schedule of ceiling fan for the first 3 months. Okay, next. So this is the process flow to manufacture a ceiling fan. So based on that, we found that among the 7 stations, the station aluminium die casting and body plate of aluminium and assembling of body plate of aluminium and rotostator are the bottleneck station. Okay, so based on that, we found that the monthly capacity is 750 units. Since the monthly capacity and the monthly demand is the same, so we only need one production line. Okay, so this table show the number of worker of the each process. Based on that, we found that the number of production worker is 15 workers for one production line. Okay, next. This is the master production schedule of for ceiling fan for the first 3 months. Okay, next. So this is the product structure of the ceiling fan, and then this is the bill of material that shows to measure to show that the cost of manufacture a ceiling fan. So we found that the cost is 189.29 ringgit. Okay, so this table show the lead time and the projected on hand for each component. Okay, based on that, we draw the time phase product structure for all components in weeks, and then it shows that the total lead time for production of the ceiling fan is 6 weeks. Okay, based on that, after that we draw the net requirement plan. Okay, this is our net requirement plan for the ceiling fan. Okay, that's all. Thank you.
Good day to Prof. Isma. My name is Brian Liwaiser. I will be presenting 2.0. So this table shows a manufacturing activity for ceiling fan. There are 12 activities in total, from choosing appropriate product to packing and keep in the store. Activity F has the longest processing time at 4 days. So from station F to L completion days for this station, are the manufacturing process for 100 units of the ceiling fan. After that, can construct an AON network diagram. From this diagram, we can know that the project completion time is 27 days. Bottleneck activities are activity F and J, and there is 6 critical paths. So we can determine the slack time for each activity using LS minus ES. So we can find that there are 0 slack time for each all activity because all activity are critical. So from this Gantt chart, we can know that activity A, B, C can be run simultaneously. After that, we do project caching to minimize completion time. All activity can be crashed, and the maximum crash time is 11 days. The crash cost per day is 3,300 ringgit. Total cost after crashing is 12,500 ringgit, and the minimum project completion time is 16 days. So this one shows the work breakdown structure of the manufacturing process. So the manufacture of ceiling fan is at level 1, the highest level. After that, we can determine expected time and variance for this whole activity using formula shown in here. So the standard dimension for this project is 1.491 days. This one is the summary of above analysis. So these two tables show the factory setup activities and predecessor activity. There are 9 activities in total. So activity B has the longest duration at 10 weeks. The activity D, E, G has the shortest duration at 2 weeks. This is a Gantt chart for the factory activities. We can know all activity can not be run simultaneously. That's all from me. Thank you.
So next, I will proceed the presentation. Before that, my name is Muhammad Ridwan bin Cik Muhammad. I will proceed the presentation with break-even analysis. So here we get data collection. We assume the value for data collection for operation time and cost. So next we calculate the total cost TC, and we got 42,000. Next we calculate the break-even analysis BEP in RM and in ARCs or units. So BEP RM we got 66,666 ringgit. And for BEPX we got 167 unit. Then we calculate profit TR minus TC, we got 198,000. After that, we construct the break-even charge. As you can see here, this fixed cost, total cost, and revenue. This is a break-even point. After break-even point, we can see that the company obtain profit as the number of unit increase. And next, I will proceed with engineering economy. So the data collection, description, investment, now other cost, machine upgrade, and revenue. So this is a simple explanation how we get this value. And as we construct the cash flow diagram based on this explanation, and we calculate the value of F using FP factor and FA factor. And we got the value of S is 348,532 ringgit. And last we calculate the value of ROR, rate of return, and we get the value of rate of return which is 38.31%. That's all for me. Thank you.
Hello, my name is Divakaran Analalaki Karunakaran, and I'll be continuing the discussion for analysis results. Based on bill of material analysis, we know that the total cost to produce one ceiling fan is 189 ringgit and 29 cents. And we also know that the throughput time for the process flow is found to be 0.21 day, and the bottleneck station have the processing time of 0.04 days per unit. Based on the AON network diagram, the project completion time is calculated at 17 days to produce 100 units of ceiling fan. We also done the break-even analysis. we can see that the required number of units of ceiling fan at break-even point is 420 units with unit selling price of 42,000 ringgit. The profit from the 750 ceiling fan was also calculated with the value of 198,000 ringgit per month. We also draw a cash flow diagram and the accumulative value at 10 years period, which is 348,532 ringgit and 23 cents. We determine that our company gets more profit over losses with a rate of return of 38.31%. Also be continuing with the conclusion. In our project, production of 750 ceiling fan are planned. From AON network diagram, it could be seen that we have 6 critical paths, as shown here. The bottleneck activity is activity F and J, which have 4 days of completion time, while project completion time is 27 days. From the crash cost of activities table, we are able to minimize project completion time with crashing cost of 3,300 ringgit per day and maximum crashing time of 11 days. Project completion time can be minimized to 16 days. To calculate the profit from production of 750 ceiling fan, break-even analysis is done. For production of 750 ceiling fan, total fixed cost is 30,000 ringgit, while total variable cost is 20 ringgit per unit. Meanwhile, the selling price of a ceiling fan is set at 400 ringgit. BEP is found to be 167 units, which is less than the production volume of 750 units. Thus, the profit obtained from production of 750 ceiling fan is 198,000 ringgit. Engineering economy analysis is evaluated to determine whether the project is worthwhile to the market or not. Cash flow diagram is drawn to proceed payback analysis and rate of return analysis. The rate of return I is determined to be approximately 38.31% per annum, while the net percent worth of the project is 348,532 ringgit and 23 cents. Thank you.